specific charge. A way of representing charged particles would be to be able to describe them in regards of their specific charge. Specific charge can only be done with the formula specific charge equals charge over mass, and mass is in kilograms and charge is in coulombs. That's coulombs over mass kilograms, or as far as A level goes, it's coulombs kilograms to the -1, where -1 is the same as the reciprocal. So when charge goes, you can never do this with a atom or a element which is in its atom. This is because atoms have zero charge, thus will never have a specific charge. Whereas when you have an ion, which are things which have gained or lost electrons, these will have a specific charge of plus or minus something. So these would be able to have something which would calculate a specific charge. So as things such as the nucleus, which only has protons and neutrons, and because there's no electrons, there's nothing to even out, so the specific charge of a nucleus will always involve protons. So how do you use it? So basically, as you know and or are learning, as far as protons go, I really need to turn on notifications, they have a specific charge of 1.6 times 10 to the -19, while they have a mass of 1.67 times 10 to the -27. Electrons have the same as this, but times -1, and have a mass of 9.11 times 10 to the -31. But in specific charge equations, this is regarded to as 0 because it's just not important. And neutrons have a charge of 0 and a specific a mass of the same as a proton. So those are the only numbers you need to know: 1.6 times 10 to the -19, and that times -1 for the electron, 1.67 times 10 to the -27, and 9.11 times 10 to the -31. Simple. So how do you use them? Say we have an element which has 4 neutrons and 2 electrons, so helium, or a alpha particle. So the question was, calculate the specific charge of the nucleus. How would you do that? So first recall the formula: charge over mass. So the charge would be the 2 protons, so it would be 2 times 1.67 times 10 to the -19, whereas the mass would be 4 times 1.67 times 10 to the -27. So these will give you like very big results, because obviously the -19 and -27 are very like different in their own regards in correlation to how much they actually mean. So in this case the answer is in 2 significant figures times 10 to the 1, 2, 3, 4, 5, 6, 7. Brilliant. And that is the whole basic of specific charge. It is literally a ratio between the charge and the mass of atoms. It can only be done with ions, because when you take into account an ion, then you also take into account the negative charge. So electrons always have a lower specific charge than a proton, because protons are obviously a positive number, while negatives are negative numbers. Therefore, when you put them into division, the negative number over the mass is always greater than the positive number over the mass. Yes. And in these calculations, when you're doing ions, you do not include electrons. Electrons don't mean anything. physics.